Hi guys, welcome to Believers Academy. So today, if I say you, in future, maybe in a decade, the world, especially the humanity, could not access the space. Is it wondering? You might be wondering why. The main reason today what we are discussing is because of this 13,000 tons of space junk which is orbiting on our Earth satellite. We all know the garbage which we see in our surroundings, even in space also, due to our exploration of source, in order to explore the space, we have produced this much of, what do you say, space junks, and this space junks which basically what will happen, it will reduce our access to the space. So that is the reason why in future decades, if we don't remove this, it will actually what? It will stop our access to the space. Okay. So in this regard, let's understand what is this space junk is all about. Okay. So we'll start. The first thing is Earth orbit is becoming a giant garbage dump. Okay, giant garbage dump. Why? Because in 1957, from the where we started that one satellite, one nation, one era, okay, the space exploration had begun, and you will be surprised to know today it is almost 15,000 satellites orbiting the Earth. Thousands are among them, more than thousands are dead. Okay, so if after this, when they expire, or the term, I mean after the expiry of that particular satellite, what it will do, we can't bring them to the Earth. So what happens is they will keep orbiting around the Earth. So whenever there is any collision between these satellites, so this will happen, this will spread into thousands of junks. Okay, these junks again they keep on rotating on the Earth's orbit. Okay, this will actually what affects our future space exploration. If in future, if you want to send satellites, this disperse will actually cause harm for that particular satellites. Okay, so this is what we are studying here. And next is what exactly is, we call them as space junks. What exactly is space junks? So basically any human made objects, the space that no longer serves the purpose, from dead to even a paint chips also. The first and foremost thing is, as I told you, dead satellites. There are dead satellites which are, which have been expired, which are their uses has been reduced. Okay, now they are rotating. Okay, this rocket stages. Okay, we actually, in order to put satellite in the orbit, we launch through rockets, and it has various stages also. So when they reach a particular stage, let's say stage 3, what we call as, after reaching there, the rockets, the remaining part will come to the ocean. However, the some parts which reach third stage will never come back to the Earth. It will keep on rotating on Earth's orbit. So even that will be there in the space junk. And next is micro fragments, which means micro fragments, even a small chips will be, will be rotating in the very fast pace. Okay, these chips also will cause a can be of greater harm. Okay, this chips as well, the paint chips and the metal sheds, millions of them travel at very lethal speed because their speeds are very high. Next is broken spacecraft. Collision between the debris will lead to collision of this, basically what, spacecraft. As I told you, the older one will actually collide with newer one, and these two after this collision will happen, will spread into numerous debris, thousands of pieces of small pieces of debris, even a paint chip also, including paint chips also, since it is rotating in very fast mode, it will also harm our future satellites. Okay, so this is about what exactly is space junk. Space junks basically what? They are even a small, from being a big large satellite to even a small chips. These can also form very, these can also cause very huge harm to our future satellite missions. So if we talk about some of the stats, the scale of problem is, you can see 13,000 486 486 tons of debris, total mass of orbital junk is circulating on the earth right now. Currently it is 13,486 tons of debris. Okay, this much of debris is there, and tracked object is almost 36,000, more than 36,000 tracked objects. We have already tracked them. These objects are what? Orbiting off our earth surface at the speed of 7 km per second. You can see how much speed, in what speed they are, rotating in our orbits. And second thing is 1 million plus small fragments. As I told you in the last slide, we saw the paint chips. These are called as what we call as small fragments. Even these kinds of, there are more than 1 million. Just imagine how much harm a small chips can form, okay, on our future satellites. Okay, so you have to understand the seriousness of this problem. Okay, so what will happen once, if they affects our satellites? Currently we are dependent on satellite for most of the thing. Either it is GPS, disaster management, okay, communication. So everything is basically, we are dependent on satellites. If a small collision will happen, the entire our technological system which we are dependent on will be automatically affected, including our Wi-Fi. Okay, so this is next thing. And where are this all junks are? Where are these junks? Basically, they are in 3 layers. Okay, these junks are basically in 3 dangerous zones. We classify them. The first and foremost is low Earth orbit. Low Earth orbit is basically what? Which is 160 kilometers to 2000 kilometers. This is the where most of the junks are there. This is the highest. This is where the highest junks is what? It is located, and compared to medium Earth orbit, which is of 2000 to 35,000 kilometers with navigation satellite and with moderate debris. And the last one is geostationary, which is more than 35,000 kilometers, where we will have communication satellites. Okay, in these 3 stages, these debris are there, and most of the debris are in this low Earth orbit. Okay, this is a low Earth orbit. And next thing, as I told you, low Earth orbit, medium Earth orbit, and geostationary, where it is these kinds of home for International Space Station, which is in lower Earth orbit. Even that will be affected also. Okay, low Earth orbit and even medium Earth orbit, where GPS and navigation satellite are there, and geostationary, where orbit is communication satellite, critical for communication satellite. So even if you, through this, what we can understand is, even a small metal or a small can cause huge destruction, where we are directly depend on them for our daily use. Okay, this is what it is. And next is, what is this? Kessler syndrome. Kessler syndrome. Basically what? This is he was a NASA scientist, Donald Kessler. So Donald Kessler in 1978, this scenario warned that the orbit debris could reach the tip point of making space flight extremely dangerous. So basically what he told is, even a small, see here, two objects are collide at hyper velocity will form what? Thousands of fragments, each pieces becoming a new projectile, which means, as I told you in the earlier start of this lecture. So basically what happens is, even a small collision between them will bring out thousands of debris or fragments. Okay, this will have cascading effects will begin. Okay, what do you mean by cascading effects will begin? So these thousands of debris will affect another debris. Okay, and that fragment will keep on affecting the other satellites. So this cycle will basically what? Continues. This is what we call as cascading effects and runaway chain reaction, where orbits become impossible for generations. Okay, where after this, if this cascading effects if keep on increasing, it will become a kind of chain reaction. Okay, this will affect our future space research. Okay, next thing is real life consequence. As I told you, real life consequence for everyone on the Earth. What will happen? Our navigation system, our internet and banking, okay, and even the weather forecasting and humans space flight and even military communications will be affected if these debris, what do you mean, persist in this Earth's orbit. Okay, this is all the effects. Even for our daily life, these debris will affect us very, it will cause huge harm for our daily life as well. Okay, next thing here is, can we clean up the space? Definitely we can. So the only thing is active removal, which means nets. We can pose nets. Hypons, magnets, and robotic arms are being tested to capture and deorbit the debris. Okay, so basically what nets are used, harpons, or even the magnet and robotic arms are being used. Basically what tested. Strong policies. The 20-year disposal rule is tightening to 5 years, zero debris. We have 25 years disposal rule. It should be tightened to only 5 years, where zero debris policy are gaining global support. Next thing is smarter design. Smarter design means refuelable satellites, modular spacecraft, and even wooden components, which was tested recently by Japanese to reduce the further waste, right? So these kinds of measures can be used in order to reduce the debris in the where Earth's orbit. Okay, global cooperation, space traffic management, and shared responsibilities are essential for orbital sustainability. Okay, so these are some of the measures which we can take. And have we taken any initiatives by the individual countries? Yes, definitely we have. We will start with India itself. India has took this project called as Project Netra. This project is specifically to bring out the debris which are there in the basically what Earth's orbit. Okay, so this is Project Netra. It is done by India. Okay, in order to reduce the debris in Earth's orbit. Second is clear space. Clear space. It is done by European space agencies. Okay, this is the project of European space agencies, and ADRAS by Japanese, and even the removal of debris mission by NASA. These are some of the mission or the initiatives taken by the different countries in order to clean up our space. So at the end, what we can understand is space debris has become a real problem. Okay, it can cause problems for future as well. So this is the reason why we have to reduce our space debris or the space junks what we have started. So slowly with cooperation, definitely we can reduce this debris if there is any in order to reduce its negative effects on our daily life, which we have seen earlier. Okay, through this we'll conclude this topic. Thank you so much.